Yes, my dear students, welcome to lesson 4 of real numbers. So we are advancing further nicely, and without wasting much time, I'll go to the higher basics of exercise 1.1. In a way, we are going to start actually exercise 1.1, not exercise 1.1 but examples based on exercise 1.1. Basically, which starts with Euclid's algorithm. The basic equation of Euclid's algorithm is A, this is dividend, is equal to divisor into quotient plus remainder. Now this is the condition, and based on this everything is going to be solved. Everything is going to circumnavigate around this. But before going further, see, if supposing I tell you that any number is divided by 3, means divisor is 3. Remember what I am telling, divisor is 3. Then what are the possible remainders? What are the possible remainders? What are they? Unfortunately, we can't interact. This is a one-way interaction. What are the possible remainders? See, my dear students, consider the divisor is 3 and the dividend can be any number. The dividend can be any number. The dividend, supposing if I take the dividend is 10, then what is the remainder? 3 3s are 9, 1. Now the remainder is 1. Okay. Supposing I go one number higher, 3 3s are 9. What is the remainder? 2. I go one more number higher. What is the remainder? 3 4s are 12, 0. See, I go one more number higher. Supposing if I go for 13, 3 4s are 12, 1. Similarly, if you go on, the remainder will be only 0 1 2 0 1 2 0 1 2. Are you getting? When divisor is 3, the remainders are 0 1 2. They cannot be anything else. Just go through this. Just think on this. What do you think if supposing I go for a higher divisor? If supposing my divisor is 6. Supposing my divisor is 6, then what do you think? Just try to imagine or try to manipulate what will be the possible, what are the possible remainders? The possible remainders. Now supposing if I go for another number, like supposing if I take another 10, again I take 10, 6. What is that now? We'll divide it by 6 ones are 6. Remainder is 4. Fine. Then again I go for 11. 6 ones are 6. 5. Then 12. 6 twos are 12. 0. Fine. 6 and dividend is 13. Twos are 12. Remainder is 1. 6 dividend is 14. Twos are 12. Remainder is 2. This goes on. 6 and then this is 15. Twos are 12. 3. Fine. This goes on. 16. Remainder is 4. Again if I go for 17. Remainder is 5. 18. 0. See, what are the remainders? Possible remainders. 0 4 5 0 1 2 3 4 5 0 1 2 3 4 5 0. So the possible remainders are 0 1 2 3 4, 5. Can you make out anything? When the divisor is 3, the remainders are, r is always either it will be greater than or equal to 0. R will be either equal to 0 or greater than 0, and it is going to be less than 3. Less than 3. So it will be up to 2, from 0, 1, 2. है ना? Similarly, here r will be, remainder can be 0 or equal to 0, and it will be less than the divisor itself. The divisor is 6, so it will stop at 5. It will never be 6. So why am I doing this? Because whenever any number is divided by 3, a number is divided by 3, where do I write this? See, a number is divided by 3. This is just basic, so I can adjust it anywhere, no problem. Whenever a number is divided by 3, so definitely this will, divisor is 3. So divisor is 3, so a is equal to what? I don't know what is a. I don't know what is a, but I know that divisor is 3. Therefore, whatever this quotient is, but the remainder will be either 0, a will be equal to 3q plus 1, or a will be equal to 3q plus 2. Bas, that's all. These are the possible values of a. You can consider anywhere. Like supposing here in this case, if you will see the a, I don't know, it is 10, okay fine, but I know 3 into 3, 9, remainder is 1. The 3 3s are 9 plus 1, 10 will be the dividend. 3 3s are 9, 3 3s are 9 plus 2 will be 11. It goes along. See, try to understand on this. Think on this. Similarly, when it comes over here, I am trying to discover my dividend now. I am trying to form my dividend now. When my divisor is 6, so see, divisor is 6, so this will be 6q, because divisor is 6. So this will be 6q, okay? 6q, then what will be the possible value of a? 6q plus 0, 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4, 6q plus 5, that's all. These are the possible values of a. If you understand this, then we are prepared to go to solve the examples based on these questions. Okay, so when I go further, now see here, what are the possible questions that we can ask? Example. Congratulations, my dear students, we are entering into the actual exercise now. Example, actually I am taking example number 3, which is from page number 6 of NCERT textbook. Okay, fine. Now here what the question is, show that any positive odd integer is of the form. Any positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is an integer. So going across, okay, welcome to the questions based on real numbers. We are going up for the higher level. Now see over here, what, as I told you, that now you have, this question deals with, you have to track the possible values of what is a and what is bq and what is r. See here, show that any positive odd integer, so any positive odd integer, this is going to be your a. This is supposed to be your a. any positive odd integer. Now what are the possible values of odd integer? 2q plus 1, as we have done that before. See here, we have done that before. 2q plus 1, 2q plus 3, 2q plus 5. Okay, and what are even? 2q, 4q, 6q, and so on. So come over here. So this positive odd integer is of the form 4q plus 1, 4q plus 3. The moment they write over here 4q plus 1, 4q plus 3, that means you have to understand your divisor is 4. Okay, so your a is, you don't know what is your a. A can be any positive odd integer, but your b is 4. Your b in this Euclid's algorithm, a is equal to bq plus r. Your b is going to be 4 because you have to prove it in the form of 4q plus 1. So when I start my solution, what do I write? Let a be any integer, positive odd integer. Okay, this is your a, and then let b be equal to 4. Let b be equal to 4. Now therefore the possible remainders are, what are the possible remainders now? Or r can be between, that is r is between what now? Either it is going to be greater than or equal to 0 or less than 4, because your divisor is 4. So therefore a will be equal to what? Now see, I am trying to show you over here in this fashion. A is going to be your dividend, 4 is going to be your divisor. Fine. So whatever you divide this with, remainder will be either 0, remainder will be either 1, either 2, or it will be 3. Are you getting this? This is a 4q, whatever this is. Remainder will be either 0, 1, 2, 3. That means it is a is equal to either 4q only, 4q plus 0 is 4q, or it will be 4q plus 1, 4q plus 1, or it will be 4q plus 2, 4q plus 2, or it will be 4q plus 3. Of course, this you don't have to show. See, what you will write? A be any positive odd integer. A is any positive odd integer. Let b be equal to 4, because they have told you that you are going to divide that dividend with 4. So b is equal to 4. In that case, the possible remainders are going to be, r is between 0, where it can be equal to 0, and 4. So a is equal to either 4q plus 0, 4q plus 0 means 4q, or 4q plus 1, 4q plus 2, 4q plus 3. It cannot be 4q plus 4, because remainder is not going to be 4q plus, remainder is not going to be 4. Whatever is the value of a, the remainder is going to be only 0, 1, 2, 3. So these are the possible values of a. A is going to be equal to what? 4q, 4q plus 1, 4q plus 2, 4q plus 3. So what have you got? Show that any positive odd integer is of the form 4q plus 1 or 4q plus 3. Now what? See, they are asking you to show that any positive odd integer is of the form 4q plus 1 and 4q plus 3 only, whereas you have got that positive odd integer 4q, 4q plus 1, 4q plus 2 and 4q plus 3. You have got 2 more. But then pay attention, we have done the basics of this also. They have told you that this a is what? Positive odd integer. This is going to be positive odd integer. So what is 4q? Is it a odd integer? No, we have done this. 4q is basically an even number. 2q, 4q, 6q, 8q, 10q. They are all basically even number. So 4q is an even number. So 4a cannot be 4q. Similarly, 4q plus 1 is odd. But 4q plus 2 is again even. So a cannot be 4q plus 2. So a is what? Only 4q plus 1 and 4q plus 3. That is what they want. So what I write next? But since a is a positive odd integer, a cannot be 4q. 4q is even, and they have told in the question that 4q is basically a odd integer. A cannot be 4q. A cannot be 4q plus 2. So 4q is gone, 4q plus 2 is gone. Therefore, a is going to be equal to, this is gone, 4q plus 1, 4q plus 3. This is what you have shown. Are you getting my point? So these are the questions. They are based on this type of questions are there, and this way we can go on solving. Of course, there can be some more basic questions over here. Now, if I go further, there is one more basic example. 1 is actually slightly mixed. There are two questions brought together in example 1. Show that every positive even integer. Show that every positive even integer is of the form 2q. That's all. Here actually speaking, one question gets over, and that every positive odd integer is of the form 2q plus 1. Okay, so you can make it now. Two different questions are there basically, and in one first question, every positive even integer, the a is going to be even, and the second question, a is going to be positive odd integer. Fine. In both the cases, the divisor is 2. So how do we start this? Let a be any integer. Now I will not take even or odd because I'm going to deal with both. So I take it at a be any integer, b be equal to, now because b, the divisor is going to be 2, be equal to 2. Then the possible remainders r can be greater than or equal to 0, and it will be less than 2, means only the values of 0 and 1. That's all. R can be only 0, 1. 0, 1. Therefore, A is equal to what? See, definitely 2q. 2q plus 0 means 2q, and 2q plus 1. You have to form this. Try to understand this. You have to form this. When you have the divisor is 4, the possible remainders are 0 to 4. We can consider the possible remainders are 0, 1, 2, 3. The possible remainders are 0, 1, 2, 3. Okay, the possible remainders. So therefore, A will be equal to what? 4q plus 0 means 4q. A will be equal to 4q plus 1. A will be equal to 4q plus 2. A will be equal to 4q plus 3. Whatever the possible remainders. 4q plus 0, 4q plus 1, 4q plus 2, 4q plus 3. So similarly here, when the remainders are between 0 and 2, including 0, then the remainders, the possible remainders are what? 0 and 1. Possible remainders are 0 and 1. So A will be equal to what? 2q, because divisor is 2. It will be 2q plus 0 means 2q. A will be equal to 2q plus 0 means 2q, and secondly 2q plus 1. That's all. So this is the condition. But then again, these are the values of A. We have got 2q and 2q plus 1. But then when for A to be positive even integer, for A to be positive even, it means when A is positive even integer, so A can be only 2q because this is odd. For A to be positive integer, A cannot be 2q plus 1 because this is odd. So therefore A is only equal to 2q. For A to be positive odd integer, A cannot be what now? It has to be odd. It has to be odd. Odd is what? 2q plus 1 is odd. So what it cannot be? It cannot be 2q. A cannot be 2q. So what is A? Therefore A is equal to 2q is not there. A is equal to 2q plus 1. Here are basics of exercise 1.1 is over, my dear students. So these examples, solved examples I have solved. I request you all people now, students, kindly solve these examples, solve the examples again and again, and then I request you all people to solve what all things? Homework, exercise 1.1, question number 1 you have to solve. Also solve question number 2. Okay, that's all. Question number 2 will be more than sufficient for you. That's all. Then later, next I will solve, later I will solve. And I want you all people to also solve exercise 1.2. In exercise 1.2, question number 1, question number 2, question number 3. Yes, you should be able to solve this. And question number 4. Solve this, my dear students. Next, tomorrow I will be solving exercise 1.1. So whatever you are able to solve, counter check that. You will be able to understand it better when I solve this, and you will be stronger in your topic. So stay happy, stay at home, stay safe, stay cool, stay calm, stay focused, my dear students. Tomorrow we will meet again and we will solve exercise 1.1. Kindly do your homework. Soon we will start with small assignments also. Hopefully we do well. Do well. Okay? Bye bye.